Okay, today we're going to review some rate of change and focus on graphing the rate of change when we have relations and functions. So a reminder about rate of change. The constant rate of change of a relationship can be determined by, so the process that we go through to determine the rate of change, we look for a pattern, right? You want to see how the x's are changing, how the y's are changing in that pattern. Well, there's a very specific order that goes in and some vocabulary you need to know. So let's fill in these blanks with the constant rate of change of a relationship can be determined by finding the change in y over the change in x. And you'll see a little more clearly today why we find the change in y over the change in x, why we're going kind of out of alphabetical order. And this becomes a fraction, change in y over change in x. Now, there are usually 3 or 4 different ordered pairs or x's and y's. And if you're drawing arrows and finding the pattern every time, it's not the most efficient process. So there is a formula that does match the change in y over change in x, and that's what we're going to use today. So copy this down. Now with the little 2 and the little 1, the numbers, it's a subscript, it goes down below and it's smaller, kind of like you've probably seen in science, like H2O. So the little 2 and the little 1 are down below, and I'll explain what those are in a second. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now what those little numbers mean is you want the second y minus, minus the first y. So add a little note here. This means second x minus first x. So that little sub 2 means the second one. So when we're comparing 2 points or 2 x's or 2 y's, we do second minus first for each. And I'll show you why we do that as well. Okay. Just watch, there's nothing to write. We're going to use that formula and start kind of seeing how it all fits in. Marcus has been downloading apps onto his new phone. The table shows the download rates. So this shows how many minutes he spent and how many apps he downloaded. Time is our x, apps is our y. Compare the change in the number of apps, y, to the change in the time, x. So again, we could, do like we had before and start comparing, right? And say, well, this is going up by 1, this goes up by 2, this goes up by 1, this goes up by 3, and we don't see a pattern. And so we start getting nervous, like, well, this isn't, something's wrong here, right? And that's where this formula actually is really helpful. Because what we can do is we're going to use this formula, this y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what we're going to do is we're going to focus on 2 points. We'll focus on these. Okay, this would be the first x, this would be the second x, this would be the first y, this would be the second y. Now take a look and see if you can figure out why I would do the second y minus the first y instead of the first minus the second. Hopefully you see that taking the second minus the second number is usually larger than the first number. So that's normally why the formula is the way it is. It doesn't always work that way, but it works most of the time. Once in a while, the information, as something goes up, something else goes down. So it doesn't work out perfectly, but it works out enough to where this is the formula. So we focus our y's first, 2 minus 0, and then our x's, 1 minus 0, equals 2 over 1, which would be 2 apps in 1 minute. Now this shows why we take the y comparison for the numerator and the x comparison for the denominator. Because if you look at my x is usually like the time, or per day, or per minute, or per session. The x is usually kind of with the unit rate, it helps us find a good unit rate. So that's why you'll see the x on the bottom. Okay. Now, because we don't see a pattern here, usually if you're told to find the rate of change, you can assume that there is a rate of change. If it asks you if the function is linear, that's when you have to start checking those patterns. But let's do this. Let's look at another 2 points. Okay, let's look at these two. So if you're still not convinced, you're like, well, the pattern's different. It isn't going up by ones. Let's do the change in y over change in x with these. So I take my y's first, 14 minus 8, and then take my x's, 7 minus 4. Again, you're just watching. 14 minus 8 is 6. 7 minus 4 is 3. 6 apps in 3 minutes. If I simplify, I get 2 over 1, which is the same. So that's a way that you can check without finding a pattern. Like if you find a pattern, or if you're looking for the pattern and it doesn't match up right, this is a more trusting way of deciding if there is the pattern or not, if there is a rate of change, a constant rate of change or not, is taking 2 sets of points, going through the formula and making sure that everything comes out the same. So the next thing we're going to look at is graphing, because that's our main focus today. Still have the same situation. Label the x and y axes and graph the linear relationship. So on our table, our first number is always the x, the second is the y. So I have time and apps. Then I'm going to treat these as ordered pairs. I have 0, 0, 1, 2, 3, 6, 4, 8. My last one goes off the chart, but you can imagine where 7 and 14 would go. And then I just connect my points and make my line. If it creates a straight line, now if you had a point out here, it's either not linear or you graphed something wrong. You should never have anything that's zigzaggy or curved. They're always straight lines. Okay. If you have a straight line, it's a linear relationship. If you have a constant rate of change, it's a linear relationship. So let's look at your first example. The table shows the bank balance after several ATM withdrawals. Is the relationship between minutes studied and her grades linear? If so, what is the rate of change? So the first thing we need to see is it linear? To do this, we know it's linear if there is a constant rate of change. That's how you test if it's linear. So we're going to use the formula. Okay, I'll pick 2 points, any 2, it doesn't matter. And we take the y's first, second y minus the first y. Now this is a case where the second number is smaller, but we still go with the same order here. Second x minus the first x. You can't rearrange and start saying, well, I'm going to do the first minus the second minus the first. Just stick with the formula, second minus first, second minus first. It's the best choice most of the time. So 140 minus 170 is negative 30. It's going to be important that you're paying attention to your positives and negatives. over 3. So it's $30 for every 3 transactions. But let's go ahead and simplify that down to negative 10 over 1. So they take out $10 each transaction on average. That's the rate that's happening. A couple other things to remember. See how my balance is going down? Because my balance is going down, that's why we have a negative. So those are things to keep in mind too when you're self-checking is if things are decreasing, you should be looking at negative numbers. If things are increasing, you're looking at positives. So keep that in mind. So is the relationship linear? Well, I can test another set of points. Okay, let's check these and see if we get the same rate. So we have 80 minus 110 over 12 minus 9. 80 minus 110 is negative 30. 12 minus 9 is 3. I got the same exact rate here. So yes, it is linear. And in my process of finding if it's linear, I was able to get the rate of change. So my final answer is yes, it's linear. My rate of change is negative 10 over 1. Oops. Okay, so let's go ahead and graph this relationship. So we have my number of transactions is X, my balance is Y. Always label your X and Y axis. Okay, so that you can keep track of what everything is. So 3 transactions is 170. 6 transactions, 140. Oops. 9 transactions, 110. And 12 transactions is 80. And again, connect those points, they should make a line. If something's off in la-la land, then it's not a linear function. However, in my work, I proved that it was. So since it is a linear function, it should make a line. If it does not, something is wrong. You plotted something wrong, or you did your math in the previous step wrong. Again, it's ways to self-check. If you see something off, go check yourself. Okay, let's look at another. The table shows the number of minutes Julie studied compared to her quiz grades. Is the relationship linear? If so, what's the rate of change? So let's take a look at 2 points. Second y minus the first y over second x minus the first x. I get 1 over 1. Easy. Let's pick another 2 points. You can overlap points as well. You could have chosen these 2 if you wanted. Okay, you don't have to pick 2 separate sets. So I have second y minus first y over second x minus first x. And I get 1 over 2. Because these are different, this is not a linear relationship. We can just say not linear. If it's not linear, I can't find a rate of change. It's not the same. Let's take a look and see what it looks like on a graph. Study time is X, grade is Y. For the most part, you don't graph relationships if they're not linear, at least in this section, but I want you to see what it looks like and how we can check ourselves. So I decided it was not linear, so I should see something weird happening with my graph. So 8 and 4, 9 and 5, 10 and 7, 12 and 8. If I try to connect these with a line, I can't. I can get a couple of them kind of, but something's off. Okay, I have an issue right here. So what you can do is you can go back and double check that you did all your math right, or double check that you plotted right, but this is a clue that it's not linear. Now, when you went to graph, if everything did line up in a perfect line, then that means your math was wrong on the last part. You did the formula, something happened with the formula. So this is a really good way to check yourself. If you get not linear, you shouldn't be able to make a line. If you get linear, you should be able to make a line. Okay, now let's look at a graph that's already done. The graph shows the altitude of a plane over a period of time. Is the relationship between the altitude and the time linear? So we want to know, can we make a straight line? That's the question here. Well, if I try to connect these, I can't really find a way to make a straight line there. Okay, let's try maybe through, oops. Let's try this again. I'll start with this point. There we go, so maybe my tool. So it does look like it's linear. But with the graph, sometimes it's hard to tell, so we're going to try this a little bit differently. Let's look at the points. I'm going to take these 2 points and we can find the rate of change, because I'm not quite convinced. Okay. We can use the formula to determine, so our y's, this y would be, let's see, this would be 3,000. So this y right here would be 3,500. This y would be 3,000. Okay, so since I started with this point on the y's, I would need to start with this point on the x's. This x is 0 minus 2. And I get 500 over 2. So now let's take a look at these 2 points. y2 minus y1 over x2, which is 6, minus x1. And I get, oops, sorry, that's a negative 2 right there. This is negative 1,000 over 3. Oops, sorry, over 4. And that simplifies to negative 500 over 2. So because these rates of change are the same, then yes, it is linear. And really, this formula stuff is the backup plan if you are not 100% sure that you were able to plot those points together. Okay, next we're going to work backwards. The graph shows how the total number of stamps Ron has in his collection is related to the amount of money he spends on additional stamps. So the graph shows the number of stamps he has related to the amount of money. So I see dollar signs, so I know that's money. And this is stamps. So find the rate of change. So to find the rate of change, we need to find points first. That's number one thing we got to do. Now to find your points, just look and see where the graph crosses grid marks. You don't want anything in between because now you're trying to guesstimate where it crosses. Find spots where it truly goes through 2 grid marks. Okay. I'm going to take 0, 0 because that's going to make my life a little easier. Okay, so let's find 2 points and I'm going to copy them down just so that I can visually see what I'm calculating. Okay, so I'm taking this point and this point. So 0, 0 and 30, 20. And then we're going to use the formula. So then I'm going to find the change in y over change in x. So I start with my second y minus my first y and put it over my second x minus my first x. I get 20 over 30, which means 20 stamps every $30. Okay. I could even simplify that down to 2/3. 2 stamps for every $3. Now, it is a straight line, so I know it's linear. I don't have to check any other points. Another thing that you can do, another way that you could find that, is you can actually make a little bit of a stair-step pattern. Some of you may have seen this before. Okay, every line that has a pattern, we can kind of stair-step here. We're going to talk a little bit more about that another day, but if you look at this, when I stair-step, I'm going up 20 spaces. When I go to the right, I go over 30 spaces. I go up 20, I go over 30, and that matches our rate of change. So again, we're going to look at that in the next lesson. Let's go one more. This graph shows how the total number of appetizer recipes Jen knows depends on the number of weeks she attends school. So now it's harder to tell which is which because they're all the same numbers. So we have to look at the question here. So because they talk about the total number of appetizers first, so because recipes is first, that's our y. And then the weeks is our x. The y values tend to be the first that's referenced. Okay. Hopefully it's a little easier for you to tell on some of these. So what's the rate of change? So I'm going to pick 2 points, any 2 that you want, copy them down. So I like to start with the 0, 0, if there is one. And then I'll go here, 1, 2. Then we'll do our formula, second y minus first y, second x minus first x. So my rate of change is 2 over 1. 2 recipes per week. That's our rate of change. I could have also done the little stair step. I go up 2 recipes for 1 week. I go up 2 recipes for 1 week. 2 recipes in 1 week. That's also an option. The formula, you do need to know that for sure. But this is a way to check yourself. How many recipes will she know after 5 weeks? So if I continue my pattern, it's 4 weeks. After 5 weeks, here's our 5 weeks. After 5 weeks, she should know 10 recipes. That's it.